Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
While it's nice to pull in packages to do various things in our projects, we need to think long and hard about how we are going to maintain those dependencies over time. In particular, how they relate to security. Supply chain attacks on software components are only going to get worse over time. In this episode, we discuss software supply chain attacks along with some things you need to be considering in order to mitigate them. While we aren't going to offer exact recommendations, we are going to discuss some general principles of what you should be considering. But before we get started, Will, what have you been securing lately? I don't know.
I've been dealing with some interesting stuff with AWS CDK setup, and it's starting to click. You know, that point where you're learning something and it starts clicking over and it's like, hey, this makes sense. Like, I'm there now, finally. Pretty happy about that. How about you?
Yeah, we are about to get started on this project. I have been battling configurations and more like release settings the past few days. Got our API set up and working. And now I'm working on the UI. I spent all day on that. And unfortunately, our architect who knows the most about the system was in interviews all day long because good news, we are promoting a couple of our junior developers, but he was interviewing them, so wasn't able to help me today. So I had to try to fend for myself. And it was one of those things. It's like, this is something I don't have access to that's not working. So I'm going to have to get him on here, not on the podcast, on here. Would be actually kind of cool to have him on the podcast, but I'm gonna have to get with him and work that out. So, but yeah, that's what's going on with me.
Saving money is hard, especially with the economic situation that we have going on right now.
We went serious with that one.
I did.
You did. Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at Complete Developer Podcast, he focuses on helping you to not only establish a real plan for your financial future, but to get to a position where you can act on that plan so that you can create the life that you want to live.
Yeah. Guys, investing in financial planning services really comes down to whether or not you can improve your finances. With the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey. So if you're feeling stressed, in the present situation, don't worry, there is a way forward.
Yeah. And best of all, Lucas is a fiduciary for his clients. And what that means is he's not here to sell you a product, but to help guide you to a better financial situation.
And you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you're probably dealing with right now. And he also interviews other people like you, other IT professionals who share how they navigated their own careers. And he has even more information available at levelupfinancialplanning.com.
The average open source non-node software repository uses 203 packages as dependencies. It's a lot. There's a lot of places where an attacker might insert code that compromises a system, introduces a security flaw, or attacks other systems. It's even worse in some platforms whose dependencies tend to be smaller and more numerous, such as Node. It's going to sound like we're bashing Node in this episode, but we actually are not.
Right.
Will wrote we aren't, but I'm like, we're going to be doing some Node bashing.
We're going to bash everybody eventually.
Yeah, basically. The issue is that Node made very clean use of small focus packages popular and easy to do so that it's useful. Unfortunately, it has some negative side effects too. Just about anything has pluses and minuses. Some of the problems that are coming for all of us have already hit the node ecosystem hard. I mean, that's one of the benefits of small. It's like what the agile approach, build, build often and fail often, something like that. Yeah. Similar issues have come in other languages such as Ruby, Java, and Python.
And I couldn't find one for .NET. I'm almost certain there is one, and I'm not using Bing as a search engine, which makes me really suspicious. I'm going to look more on this later. But yeah, the node thing, it does sound like bashing, but what it really is the fastest car gets to the grocery store first, but it also goes over to the cliff fastest.
Yeah.
And unfortunately, node is the fastest car in the present environment. In effect, most of the code in your application was not written by you. And this has almost always been true for the entire history of software development, at least as long as we've had libraries. If you did old school console apps in DOS, you probably still pulled in dependencies from libraries for at least some of the work. Or you had a framework that you were sitting on top of, right? Like you were not, directly interfacing with the devices on the system or the file system at a low level. However, we have a more modern, hyper-connected world, and the number of available software packages, package repositories, and the security concerns that go along with both have completely exploded. There's a very serious risk that in the near future, some major security problem is going to bring down large numbers of applications. In much the same way as the I Love You virus did to email servers back in the day, we're kind of at a similar risk of ingesting code that we don't necessarily want to execute in a particular environment. The issue is one of trust and security. In fact, one might argue that it is the same issue that we've been grappling with in computing since the very beginning. Who do I trust, and how do I prove that it's really them and that I can still trust them?
In the movie Jurassic Park, I love how I got to do this one because I always make movie references. That's awesome, dude. Perfectly late.
Well, we just watched it Friday night.
You did? I haven't seen that movie in forever. Anyway, in the movie, they use mosquito-extracted blood for dinosaurs in order to clone dinosaurs in a lab. However, there are parts of the DNA that are damaged and can't be replicated effectively. So what they do is stick some amphibian DNA in the gaps. Essentially, they are behaving in the way that thousands of us do every day. In the movie, this resulted in dinosaurs that were supposed to be contained, as in they were not supposed to be able to breed because they were all female. However, an unexpected feature in the inserted DNA caused them to be able to change, and people got eaten. We also have to face the fact that while we like to think of ourselves as being the brilliant mathematicians who saw it all coming, on average, most of us are like the big guy, Dennis Nedry. I forget how to pronounce his name. Nedry. Yeah, I haven't seen it in so long. Who didn't realize how dangerous the situation really was and was just trying to collect a paycheck.
Yeah.
And another paycheck, if I remember correctly.
Yeah.
Yeah. And, shaving cream.
And he was, trying to hit the vending machines.
Oh, yeah. Yeah.
like the fist of an angry deity. In this episode, we're going to discuss software supply chain attacks and a bit of philosophy for making them less frequent and less damaging. While a larger discussion is merited, it is outside the scope of this episode. And what we really want to do here is to help you overcome your inner Dennis and be at least somewhat capable in a changing and more dangerous world. In the aftercast, we'll discuss the threat of insider threats of supply chain attacks and how to mitigate those. I said threat twice because it's threat squared, bro. I saw the smirk.
Actually, I was thinking something completely different.
Okay.
But yeah, I was like, you're like, don't be Dennis. Remember those Don't Be Dave commercials?
Yeah. Yes.
So this is the Don't Be Dennis episode. Yes. All right. First off, we're going to go over some of the recent software package supply chain attacks. And this is recent as of April 2022 when we are recording this episode. There may be more
April 12th.
April 12th, 2022. That's true. It's early to mid-April. So yeah. So this is when we're recording it. This will come out, I believe, in May. So there may be more after this. And then if you're listening to this,
there will be.
Years later, then this is what's going on now in the world around us. So the first one, Vue.js users were hit with a pro-Ukraine supply chain attack that deleted files in Belarusian, and Russian IPs. The package with the issue was Node-IPC. What did that package do?
Inter-process communication. And that package is used in a lot of places. When this came out, we were scrambling around at work going, okay, are we using this down in our dependency tree anywhere? Of course, it made me panicked because, guess what character set I have on my system?
Oh, yeah. Oh,
right. When you're learning the language, you kind of need that. And it's like, are you going to nuke my system because, because of this? So the next one, there were Monero miners. Monero is a cryptocurrency in NPM packages that impersonated the UA-parser-JS library. So this was essentially where somebody took advantage of a typo squatting error and slipped the package in that way. The Node event stream library is another one.
So the next one is the Node event stream library was taken over by a new publisher. One of the dependencies, flat map stream, was then later compromised. And this is a big issue too, is when you've got one that's been like, you have a library that's been consistent or a package that's been, well maintained and consistent, and then it gets bought or taken over by someone else.
Ruby Gems got hit with a typo squatting attack that added more than 725 malicious packages that intercepted Bitcoin payments on Windows devices during a period of about a week. That's pretty nasty.
PyPy, that's PYPI, had a malicious clipboard hijacker that was an instance of typo squatting from Colorama. They used the British spelling of color.
Yeah, so they just put a U in there. So U is the problem, as I've always heard. And finally, another great example of this that's perhaps a bit older, but is still out in force. WordPress plugins and themes are a continuous dumpster fire.
Oh, yeah.
Regards to security.
I was helping a friend of mine. She had someone else build the site for her, but didn't she's just not techie. She's an artist. And I was helping her figure out stuff on her site and how to do things. And I saw some stuff that we no longer use. And I'm like, hey, you might want to talk to the person who put this together for you, because that package has been compromised. I'm not going to say which one, but
it's start with an A.
Yeah. Yeah. I was like, we don't use that anymore on our site. And, because I know the person who built it for us. Like, if we need to talk, that's fine. Just tell her to call me. I can explain, but you really need to ask her to get rid of that.
So let's talk about why these attacks happen. Because when somebody's coming at you, you kind of want to know their motivation, because that's how you find a way to stop them. They are not all script kiddies and spammers. Back in the day, it was, some 17-year-old, face covered in pimples. It's like, okay, I'm going to break into this system because I want to prove I'm a hacker, right? That was like the old trope. It's not entirely really true, but there were a few of those dudes around. And then there's obvious, spammers. Well, the situation now is a bit worse. There are people that are just jerks. I used a different word when I wrote the outline. Beach didn't like it, but it's probably fair. But you have people that just simply snap, right? And, for instance, it would be very easy for, I don't know, some dude goes through family court, gets a divorce, loses everything, and decides to put out a package that tries to determine if the user is a woman and attacks the system.
Oh, like White Plague. Yeah, it's a novel by Frank Herbert. The writer of Dune. Yeah. He wrote other books.
Yeah, I mean, so you just got people that they're unstable or they're mad about some issue, and they just, something pushes them over the edge, and this is how that gets expressed.
Yeah. It doesn't surprise me. I remember when we were in college, I had a friend who was going to ITT Tech. Yeah, that was wow. That's been a while. That's been out of business for a while too.
I was going to say,
Yeah, when we were in college, I had a friend who was
while
going
working at
there.
Blockbuster.
Actually, I think he might have. I don't know.
Yeah.
But anyway,
You should fax him about it. Sorry.
He told me he came into talking about people just being jerks. He came in to the lunchroom one day and some guy was like in there bragging about having like written a virus and released it the night before. And he was like, I want to say it took everything I had to not punch him in the face, but the urge was stronger than everything I had.
Oops. Yeah, I don't really feel bad for the victim or but the guy who got natural consequences.
Yeah. No. So anyway, that just cracked me up because I'm like, yeah, the guy was just that. So the next reason why people attack is they're activist, which is a subset of jerks.
Yeah, I mean, like, you have people that are working towards a goal. They're trying to fix things in some way. This kind of stuff never fixes anything. This is just somebody acting out because they're emotionally incontinent.
Yeah.
And that's all it is.
There's a difference between, what is it, hacktivism? And most of like the hacktivism stuff I see is people going and building things for nonprofits or building things for people who need them. Like then there's the, Mr. Robot-esque stuff, I guess. I don't know. I only watched like part of the first season of that show, so I'm not really sure how it went.
I'll tie this together. The guy that did the pro-Ukraine supply chain attack and deleted files, right? Activist. He thinks he's helping. Well, what happens if there's a human rights organization over there that is documenting human rights abuses during a war, which all wars have them, right?
Yeah.
And hey, they're not operating right out of the war zone, but they're operating next door, and they happen to be in Belarus, and their data gets deleted. It's like now you covered up something, essentially. Like, literally by your bad way of trying to help, you made things worse.
Yeah.
That's why I put activists as a subset of jerks, because that seems to be the main thing they do.
Yeah.
Next activity is mining crypto. This used to not be a thing because crypto wasn't a thing. Once crypto became a thing, due to the computational expense of mining it, it's a lot nicer if you can put that work onto somebody else's machine.
Mm-hmm.
And
I have an episode about mining crypto and understanding what that process is, because I get asked that a lot. So
yeah, I do too. I don't know if I can explain it well enough, but we'll have to see about that.
Maybe we can find someone who could come on and do that.
Yeah, that'd be a good idea.
So the next one is viruses, malware, spyware. This is, things that get put in there to steal your information, your identity, your credit card numbers,
steal passwords. There's all kinds of things that can do that lead to bigger things, right? Like that's just a subset, because you might issue some malware that lets you control a whole bunch of machines, and you put Bitcoin miners on all of them.
Yeah.
Right. This is the scaling factor for a lot of the other stuff. The next one is data theft and exfiltration. So instead of actively damaging systems, they get in and they find a way to get data out. You connect to a database, it's in the same process space, and you're able to pull a connection string and get the data and ship it out.
Yeah, that's where you get all those WikiLeaks from.
Yeah, there's a lot of leaks that have happened out of a lot of different orgs by this.
There's that, and one thing I don't exactly see on here is the name of it just bounced out of my head, but when they get into your system and they block you from accessing your data. Ransomware.
Yeah, I kind of put that as viruses, malware, and spyware, but yeah, it's the same.
Yeah, see,
thought process.
Yeah, I'm thinking kind of like it's sort of like the between these 2 points, the viruses and the data theft. There's sort of that ransomware, which is another reason, and that is pure just to get paid. They're breaking in to get you to pay them money. So,
well, That's also a way to get crypto, usually
Well,
from other without having to work for it.
yeah, that's true. That's true. Then there is terrorism.
Right. And you don't see a lot of this yet, but it would be very easy in some systems to get in probably and do damage that actually harms or kills people. And this could be anything from actual, stuff exploding type terrorism to, we're going to break something that takes down a substantial chunk of the market and makes it so that people don't have jobs. Like, a great example would be, was it Atlassian? They've got this major outage that's been going on for quite some time. If somebody did that on purpose to break their business, it's a little bit more than malware, but it could be part of a larger scale thing. And speaking of,
Yeah, and there's also like corporate espionage too.
right, or just damaging your opponents,
Mm-hmm.
there's a lot of stuff that's a bit bigger than it's just malware.
Yeah.
We did some stuff, I think, to Iran, I want to say, to their enrichment facilities.
Mm-hmm.
The U.S. did, to make it where they couldn't enrich uranium. There's going to be those kind of things. Which, speaking of which, the last category is state actions. We've had a period of relative peace. Peace is abnormal, and we're entering a period where we're going to realize that, I think. So you do have the potential for state actors to start doing things. Obviously there is, there's a situation in Eastern Europe right now that's on everybody's mind. There's situations in the Middle East that are not on anybody's mind except the people that live there. They're pretty harsh. There's other ones that are upcoming. There are potential state actors who are not necessarily the most competent people in the world in some of those cases that may do things trying to hit somebody else completely different, and they end up hitting your system, or they, use your system as a bridge and they do some kind of false flag. There's a lot of stuff that can really happen here with this kind of escalation into this territory, especially with packages, because now you're getting into controlling more machines, more expensive machines, more connected stuff. It's not, consumers and prosumers. It's, corporate.
Yeah. So now let's get into discussing what they are attacking, since we've already talked about the why. And the first one on here is the developers' machines. And this is sort of honestly, I'd say this is probably one of the easier attack surfaces, because we're constantly trying new things and pulling in packages that we're just testing out to see if it even works with our system.
And a lot of times without a whole lot of vetting and without,
Yeah.
Hey, we're going to stick this in a Docker container so that it doesn't screw anything else up. I mean, you can bust your system even without it being malicious. I did that plenty of times with all kinds of software packages. I know I've done it with Ruby, and I know I've done it with Node for sure, in the past. And that wasn't even a breach. It was just, I was an idiot.
Oh, well, at least you admit it.
Right. That's the first step in the 12-step program.
Yes.
Now, another thing that gets hit that people don't tend to think about too much is build servers. Your build servers need to be secured, because guess what builds the artifacts that go out into production? It also builds the artifacts that potentially are running code on client machines in other networks.
I mean, this is a big thing, because we think about protecting our own machine because we don't want to deal with the annoyance of something going wrong on there. And then we think about what's out in production and stuff, which we're going to talk about in just a minute. But a lot of times we don't think about those builds, because honestly, I didn't think about them that much until I started working on this release pipeline. And I'm looking at it going, hey, if I get a bad build, then that's going through the whole pipeline until I start another one. And it's if you get something bad in there, it could go all the way up if you're not careful and you don't have those. Well, we have several checks and balances, but
Yeah. A lot of companies don't, though. I mean, I've seen things that are concerning. Now, another thing that gets hit, which is obvious, is your production machines. Understand that the concept of your production machines is probably broader than what you would actually consider to be prod. These would include demo machines, like a client comes and they check out your software and you walk them through a demo of it, or your development machines that are publicly exposed on the open internet.
Yeah.
Right? Like your QA people are hitting these things and going, okay, yeah, we're going to go through and run a set of tests. This machine's exposed on the open internet. Other parties could hit it, or it could exfiltrate data. That's still production far as I'm concerned. It's not prod for developers, but it's production in terms of, hey, it's public.
Anytime it's outside of your network, it's production.
Yeah.
That's the way I view it, at least from a security standpoint. That's what I try to tell people too. It's like, yeah, that's test, but it might be UAT, but it's still available on the internet. So it's production. So we got to treat it like that.
And I've had to yell at people before who were using the same machine for prod, QA, and dev, same physical box.
What?
And putting the different sites on there. And it's like, if dev gets compromised, like, you're toast.
Yeah.
What are you doing?
I know, right?
And devs screw up and break things too. Do you really want to break in prod? With some never ending for loop?
Forever 4. It's like Forever 21, but not as cool. Sorry.
Forever wow.
All right. So the next thing that they're attacking is users of websites.
And there was a supply chain attack fairly recently where it basically detected if you were, and this is again with the Russia-Ukraine thing, if you were in a time zone that is shared by Russia. Bear in mind, they're not all the way to the South Pole. So like there's other countries in those time zones. It would display a message on websites, with some stuff about, what was going on over there, intended for a Russian audience, but it's hitting other people's sites. So like India, there was, obviously that's a problem there. And it turns out that India's got a fair few people in it.
Really? You don't say.
Yeah. So does China right next door. And, so you can imagine if let's say that, one of your customers happens to be a country that is in the affected zone. All of a sudden now it looks like you're putting out, you're taking a side in a conflict that, you may or may not agree with, but it also looks like your site's compromised. And it could, this time it displayed a message, but it could have easily been XSS. It could have done any kind of, other kind of stuff down to some pretty destructive things.
Mm-hmm. And then finally, deployment pipelines and other dependent parties are users of your packages. So like if you use the packages that you use may be compromised, and then you put out packages using those packages. So anything that you put out is therefore compromised.
Yeah. So like if your company ships an SDK because you're, very heavily oriented around API stuff, guess what? That goes out through a bad build and it's on your client's machines. And by the way, they trusted you. And that may even be, signed with your key and get out that way. So let's talk about entry level defenses against this kind of stuff. And these are the basics like, I don't eat paint chips, therefore I do these things. So the first one is having reproducible builds. So you don't ever pin to whatever's latest. You pin to a particular version on your package manager. That way, when you build again, you get the same thing. That's also necessary for actual good QA to happen. But this also keeps you from doing a rebuild and thinking things are fine and some malware has gotten in, right? And you haven't tested in between because it was just a little point patch that you did. And you're like, oh yeah, we've already tested all this other stuff. There's nothing related here. It's like, yeah, but this package updated and now there's malware code that's going to prod.
Yeah.
That keeps those kind of gap slips from happening.
Next is signed packages.
You need to know who actually wrote the package and deployed it. The name of the package is not enough. There's a cryptographic signature. If you don't have that and you're not checking it, you are just waiting for a problem to hit you.
Yeah, and this is just an entry level defense because like we said earlier, it could actually be the package manager, like the package creator who's doing the bad stuff, or they could have sold the package and the new manager is doing that.
Or one of their dependencies is busted. They pushed an update that they thought was sound.
Yeah, that's true. Next, you really need to have automated QA processes.
Yeah. And now you might go, okay, well, this isn't going to catch everything. No, it isn't. But what it will catch a lot of times is when the malware authors or when the compromised packages are doing something that they shouldn't do, a lot of times those break things as part of it. And so your QA process isn't going to necessarily catch the malware. It's going to catch a side effect of the malware and keep crap from getting to production.
Yeah, I've had to explain the concept of like, cause we do automated testing and stuff, but I've had to explain the concept a couple of times to junior developers that I work with as to like, all right, you're not actually testing anything with this test. Like you have a lot of code here, but like sometimes they'll create an object and then test whether the object that they created existed. And I'm like, that doesn't actually test anything.
Yeah. Unless
Like,
you
oh,
don't
no,
trust your framework.
I'm calling the code right here. I'm like, yeah, you're calling the code, and then you're saying, hey, did this object that I created, does it have the value that I put into it? Which didn't happen in the code. It happened before you called the code. And I could get on into like issues with automated testing and stuff later, but like it's not just having it isn't enough is what I'm getting at. You got to look at it and make sure you're actually testing what's going on.
Well, the other thing with automated QA is if you do find that there is a vulnerability or some rising problem that's in a package, when you replace it, you want to be able to get that out as fast as you can. And the automated QA means that you're not spending months, hand testing things because you only roll out an update every 6 months. Right? Like those days are gone. You're not going to be able to do that anymore. You're going to have better stuff. The next one is minimal permissions. Any piece of software that you are running should not be running as an admin. It should be limited in what it can do, what files it can touch, what databases it can get into, what secrets it can get a hold of. You're definitely going to want to lock that stuff down because when malware hits, a lot of times it's going to hit those permission boundaries and that's going to raise a red flag. And yeah, it stinks that it breaks your site, but it's not harvesting credit card numbers from your clients.
Yeah, that's a big thing. With permissions, you want it to have everything locked down and then start allowing stuff.
Yeah, once it's proved that you actually need it.
Yeah, because otherwise you don't need it. Next is version pinning.
So you use a particular version. We kind of talked about that in the reproducible builds, but this is also true at the developer machine level, so that you don't upgrade until it's intentional, essentially, so that it doesn't just happen, because that's a great way to get a compromised development box.
Yes, which if you have Windows machine, you may not be able to do that.
Oh yeah, like Windows itself. Yeah, I noticed today. Yeah, stuff updated on me.
That's why I like Mac.
So next one is package caching. So you probably are going to want some kind of package management server on your own infrastructure, and you want to set that up in such a way that it proxies, which I was going to talk about in the next point, but I was talking about it now, so that it proxies to the real package server. When you download a package, you hang on to that on your local cached infrastructure instead of pulling it from this other server all the time. Part of the reason for this is just speed and stability because you're not as dependent on these others. But the other thing is that server is probably going to be locked down a little bit more. And you can essentially say, okay, this is the target for getting any packages. Do not add another registry because that other registry may be compromised.
The next one is package scoping, where that's available.
So you'll see this in Angular a lot, and you'll see this in a lot of, especially the Node ecosystem, where they have the @ /. Essentially, what a scope is, it's kind of a region of packages that are maintained and kind of controlled by a particular entity. And so, if you do not have the permissions, you cannot add a package to that scope. And so, it keeps somebody from doing, oh, hey, let's rename Angular to @Angular, or something weird. Let's misspell the word Angular so that this, we can get this malicious package out there and people will download it. Well, if you scope it, that makes it less likely because they can't push it in there where you pull it, even if you did misspell. And let's be honest about developers spelling. It's not great.
Oh yeah. No, we have particular developers I work with who are known for their horrendous spelling.
Yep. Same here. Sometimes it's me.
I would say most times it's you, but that's just my
nope,
personal experience.
I got a coworker that's worse. I got a couple of them that are worse than me.
Oh, that's impressive.
Yeah.
If they are listeners to the podcast, I am impressed. Good job, guys. Keep it up. All right. So finally, under entry-level defenses, pay attention to transitive dependencies.
That's the dependencies of your dependencies and their dependencies. All the, basically the legs on every turtle below the first one.
Watch that tree, because if you're not careful, it can really bite you.
Yeah. That tree gets pretty deep and will definitely be something you watch. In other words, don't just look at the top level packages when you're determining whether a rising threat is a threat to you. You've got to go in.
Even if it's not.
It could be tomorrow because you updated a package.
Well, no, what I'm saying is even if it's not a malicious thing, like I ran into an issue just a couple of weeks ago where we upgraded and one of the dependencies, or like we were starting a new project, and so we went with a newer version of a package that we had been using before, and one of their dependencies had changed, and so some functionality just wasn't there, and we're like, we need this functionality. We looked for like the change record and go, all right, hey, okay, you've changed this, how do we do this now? And it was, oh, we don't think you should be using it this way, so we just took it out. There's no way to do that.
Thanks, bro.
I'm like, yeah.
We'll remove your entire package now. Thanks.
Yeah.
Because we can't trust you.
I'll just find somebody else who I can Yeah, but that was an interesting thing, and it was on a dependency of the package we were going for. So like you didn't even see it in their change log.
Yep, because it wasn't theirs.
Yeah, it wasn't, and so it was a tricky one to figure out why that wasn't.
Now
working.
right click on one of your node modules folders and go to properties and see how many files are under there, just to get an idea of how important this is. So, beyond the entry level defenses, there are some things you can do. Once you're doing the bare minimum to not get immediately nailed, you need to do more stuff. One of those things is package audits. You should have some kind of security process when you've decided to add a new package to go, okay, like I need to vet this thing and see what its dependencies are and vet those. And you also need to kind of be aware of threats as they're coming out. So you'll need to probably subscribe to some security newsletters and actually catch these things and have the ability to quickly look in your code base and see if it's a problem for you, and do that on a regular repeating basis instead of waiting until a threat occurs.
Next, use more microservices.
If your code doesn't do much, your surface area of attack is not as big. You can restrict what that microservice does. If it doesn't need access to the file system, and it's separate, that don't give it access to the file system, your file system risks are negligible at that point. If it's part of a monolith, that's not as easy.
Mm-hmm. Like that's one of the big benefits of microservices. Also, if one gets compromised, you can just literally pull it out and replace it with something else.
But if it's small enough too, it makes it a lot easier to test it to get a replacement out. You should also do automated package vulnerability scanning. There's tools like, was it Dependabot that will do that? And they'll look for risks. I think NPM has some stuff as well where they're like, hey, this package is way out of date or there's some kind of problem with it. It'll tell you on the command line. You need to be using those frequently.
Finally, automated intrusion detection.
So the systems, and this is not really a dev concern. It's more like a DevOps or system maintenance concern. Your system needs to throw a red flag when something starts, communicating over the network, especially to outside parties that you don't recognize, because it may be exfiltrating data. They may be downloading other programs to run and break things. That is something to be very aware of.
No. All right. So now let's talk about some longer term fixes. First off, limit the number of packages you pull in. I mean, the fewer packages you pull in, just like with microservices, the smaller your attack surface.
You should also limit who can pull in patches. The new junior dev that you hired yesterday probably doesn't need to be able to do that into stuff that's going to production without it being thoroughly vetted. And he probably just really doesn't need to be doing it, period. It's a little different in Node. I still would kind of push back on it even there, but especially in like .NET or something where a package is huge, not doing that.
Yeah. Next, package sandboxing.
Yeah. There are platforms that will let you do this. .NET used to have a thing called code access security where you could say, hey, I'm running this in what they call an app domain. And I could say this app domain has a restricted set of permissions. I still communicate with it within my app, but it can't do things that the rest of the app can do because I don't trust whatever's in there. It's really good for plugin models too. I want to say that Dino, which is like the alternative to Node, because I just decided to play parkour with the letters. That one, if I remember correctly, has got some features headed this way. I don't think they're there yet. Finally, you do also need to have continuous deployment or at least frequent deployment. Like it should not take you more than a day to get something out. Because when you find one of these things and they are becoming a risk, you do not want to be sitting there screaming at your QA to hurry because the server is going to get nailed. Right? Because you could dodge malware and then just run face first into something that still breaks your system.
Yeah. All right, guys. So a few takeaways from this episode. First off, the days when we could actually trust random code from the internet never existed. The days when we could get away with doing that are gone. And they actually have been gone for a while, but in some cases we've been able to sneak past it and just been lucky. But yeah, we can't trust random code from the internet. It's why you don't copy and paste code from, even Stack Overflow or anything like that. Yeah, you gotta vet it. And if you don't understand it, you do not use it. The second takeaway is that any update that occurs has to be assumed to be malicious. You prove that it isn't. Otherwise, it's not trusted. Yeah. And the last one on here, defense in depth is the only way.
Right. So if you're relying on a single one of the strategies that we listed and not relying on the others as well, something is going to get around that strategy. You basically just want to have enough barriers so that it is hard to hit you and they'll hit other people instead of you. Right.
Yeah.
You don't, you're on the savannah. You don't want to be the slowest gazelle.
Exactly. So guys, supply chain attacks are a real and rising threat to software development groups everywhere. In addition to the motley cast of script kiddies, Will's wording, cryptocurrency miners, spammers, pranksters, not that I haven't done anything of that in my lifetime, and malware vendors, there's a growing problem with issues from state actors, terrorists, and international cartels. On top of all of this, you have to worry about insider threats as well and breaches at trusted partners. We're going to have to improve our game in this, or the results will be catastrophic. Supply chain attacks are very serious problems and probably the greatest threat the industry will face in the next decade. That pretty much wraps us up. Check out the aftercast where we are going to discuss insider threats from package supply chain attacks. Catch you guys next week. Wait, that's how I end the aftercast, not the episode. Oh well.
Yeah.
I'm not used to having to end. I'm not used to ending it without the. We'll figure out a way to end it better. But yeah. So that's that.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.